The possibility of a catastrophic asteroid on course to slam into Earth is extremely rare, but experts say it's just a matter of time before this threat becomes a reality. To prepare for such an event, NASA has teamed up with the Federal Emergency Management Agency for a series of exercises intended to simulate an asteroid emergency. In the most recent exercise, the experts prepared for a hypothetical object 300 to 800 feet wide approaching far too quickly to be redirected, necessitating a mass evacuation of the metropolitan Los Angeles area with 100% chance of impact. It's not a matter of if but when we will deal with such a situation, said Thomas Sorobakin, Associate Administrator for NASA's Science Mission Directorate in Washington. But unlike any other time in our history, we now have the ability to respond to an impact threat through continued observations, predictions, response planning and mitigation. The simulation was carried out on October 25 in El Segundo, California, and allowed the planetary science community to demonstrate the ways in which it would collect, analyze, and share data about an asteroid predicted to collide with Earth. And emergency managers explored the ways in which this data could be used to prepare and warn the public and respond to a potential threat. The exercise included experts from NASA, FEMA, NASA's Jet Propulsion Laboratory, the Department of Energy's National Laboratories, the U.S. Air Force, and the California Governor's Office of Emergency Services. It is critical to exercise these kinds of low-probability but high-consequence disaster scenarios, FEMA Administrator Craig Fugate said. By working through our emergency response plans now, we will be better prepared if and when we need to respond to such an event. In the hypothetical scenario, researchers detected the fictitious asteroid this fall with a 2% probability impact with Earth on September 20, 2020. The initial estimates stated that the impact could happen anywhere on a long stretch of Earth, including a band that crossed the entire U.S. But in the fictitious scenario, observations with ground-based telescopes tracking the object for 3 months determined the chance of impact would actually be 65%. Subsequent observations were then delayed 4 months due to the asteroid's position relative to the Sun, and when they resumed in May 2017, the hypothetical impact probability had jumped to 100%. By November of that year, the researchers say the fictitious asteroid would strike somewhere along a path between Southern California and the coast of the Pacific Ocean. This scenario describes a time frame that's too short to feasibly conduct a deflection mission, meaning the emergency managers must evacuate the region. To do this for the hypothetical emergency, the researchers presented models of the predicted impact footprint, population displacement estimates, and data on the infrastructure damage that would result. The high degree of initial uncertainty coupled with the relatively long impact warning time made this scenario unique and especially challenging for emergency managers, said FEMA National Response Coordination Branch Chief Leviticus A. Lewis. It's quite different from preparing for an event with a much shorter timeline, such as a hurricane. The simulations allowed the researchers to devise ways to accurately inform the public in a timely manner while fighting the rumors and false information that would emerge. These exercises are invaluable for those of us in the asteroid science community responsible for engaging with FEMA on this natural hazard, said NASA Planetary Defense Officer Lindley Johnson. We receive valuable feedback from emergency managers at these exercises about what information is critical for their decision making, and we take that into account when we exercise how we would provide information to FEMA about a predicted impact.